made super simple presentation in the previous one because I built the GoVisual to be a simple actually. This is not this is not super complex stuff, but I built GoVisual last year, and surprisingly, it's got a lot of stars in the GitHub, and I'm still getting more than 30 downloads every day. So I have to. So this me. So I've been coding for the last 10 years, and these days I'm building a lot of open source projects, mostly called writing improvement for the developers. And I realized that all the tools and all the abstraction layers that we are using in these days is getting more complex, making our life more complex, right? So the always abstraction, always hard to debug, hard to understand what's happening, and it's this is the problem that while we are writing some web applications, so when you are trying to debug what's happening in your code, in your requests, especially, you have to write a lot of debug lines, the print lines. That there's a lot of crowd in the code. So, and these are the common approaches that I've been found. So you can write the prints, variables, curls, log files, Postman, the Jaeger, there's also libraries for like Jaeger, but especially for the development stage, for the local users, these are very overkill, creating a lot of noise in your code. So the GoVisual is just one line, right? So you just wrapping your the instance with the GoVisual. It automatically opens the endpoint in the browser. It's pre-built dashboard, and you can track all your queries and the SQL statements that bound with these requests. So this is the architecture that I'm following while doing this. So when your application, when your instance now getting the request, just before your the business logic handler, I'm just intercepting these requests without touching any detail inside, capturing it, and letting this request through your the business logic handler. And while getting back to business logic handler, I'm intersecting it the second time for getting the response. The times and the status requirement SQL queries just happen while these requests coming through. So this is the heart of the GoVisual, actually, like a lot of middlewares. So basically, I have created one object that includes all the methods and the paths initially, and because of we can't after you write in the response writer, you can't read again, right? So I had to write one wrapper to your response writer, and I'm capturing everything happens in the response writer, and passing through the request to your business handler, and everything, and I'm storing the request data. And after the while I'm storing, I'm broadcasting to you guys. So I'm going to show you how it works interactively. And this is the response writer wrapper that I wrote. So it's basically wrap the response writer. Why I decided to wrap it, as I explained in the previous slide, there is no way to read HTTP response writer after you write, right? So anyway, we have to wrap it for putting the operation on it. So your application has no idea. We're not touching your business logic, and we're not adding the latency to your business logic. So, and for the front end side, because as I mentioned that I build a front end, this is pre-built actually. When you install the GoVisual to your project, it's automatically downloads with it includes the distributed front end inside. So basically with the loop that I'm passing the server-side events to the front end. With this, as I said, I built this to make it super lean and simple. So I don't want to write any web sockets, something like it. So it's super simple. That it includes the server-side event. And I think this is one of the best thing that using GoVisual. When you, I'm passing to the context of the request through the nested. So with this, we can track all the SQL queries that happen with your request. Right? So what's happening in these requests? Because I realized that most of the big framework already includes this feature. Like Laravel has this feature, Rails has this feature, like this Django. You can find a lot of the library that they implement this stuff. But there's nothing in Golang, and of course everyone needs the observability right now. So this is the context pattern that I wrote. So I'm passing there is nothing anti-pattern of the Golang. So the basic, I'm passing the tracer to the tracer of the middleware tracer to the context. So with this, you can write all these queries. Maybe if you like to track anything else that you like to track your requests, that you can pass into the tracer. And this is one and only data model that I have now. So basically, it includes the ID and the method of the request and the path, status code, and the duration, and the headers and the bodies for the response request. And also, I added one middleware trace, so I'm passing all the traces into just one, the parameter there, and you can read all the traces within your request, even they are, the unbelievable nested. Yeah, for the storage interface, I started everything with the in-memory storage, but I got a lot of pull requests that people going to implement their own storage, the different storage stuff like, the SQL, the PostgreSQL, the Redis. Maybe most of the people using Redis and MongoDB. I have a lot of different currently implemented database type in GoVisual, but most of them are community driven. People just open the pull request, and I'm trying to keep it internal. So this is the demo I have. Demo there. Just a second. So this is the dashboard of the GoVisual. Right? So let me clear all. Okay, this is the dashboard of the GoVisual. As I said, when you implement the GoVisual to your application with just one liner, this dashboard automatically, is serving your application. So, and in the right side, I have the another web page. So this is the mock data I prepared for this presentation. But basically, it includes all the endpoints that all these applications. So, for example, when I open this web page, so basically, it's automatically comes from the, requests come to API users, and these are the headers. These are the bodies, the request and the response. And this is the trace. These API requests, these HTTP queries just happen, and this is the performance implication. Actually, what is the CPU time and memory, how many algorithms just passed through, and what's happening in the Go compiler. And I have, the little dashboard there, logging the request, and these are the analytics. I love playing with the analytics there because I'm using the GoVisual mostly running the tests, right? So I'm running the tons of requests that I'm trying to understand what is the implication of my application. So after running the test, I'm getting a lot of different request logs there, right? For example, you can run this, like this is another one, so there's a lot of different data happening there. For example, I can see how many SQL queries is happening with this request, and it's also allowing me to understand N+1, the problems like N+1. And lastly, I also added some places for understanding environments in the request trace. These requests is something like a flame graph that you can understand how many queries is happening with per request actually. So as I said, it's very simpler because it's built to be simple. It's just one-liner, and yeah, this is the dashboard here and framework support. The GoVisual supports the most of the most popular web framework because it's bind itself to NetHTTP package, right? So, and it's development only. I prefer that not using the GoVisual for the production because the production you have a lot of different the options there for the tracking application.